Hello everyone, this is the 8th video of Chapter 3, Difference of Squares. In this video, you will learn how to factor binomials that are the difference of squares. Also, you will use the difference of squares to solve equations. The binomial expression a squared minus b squared is called the difference of two squares. The following pattern shows how to factor the difference of squares. They're saying, again, if you had the difference of square, a squared minus b squared, this can be written as when you had a minus b times a plus b. The order of these two terms doesn't matter, so you can always write a plus b times a minus b. The reason that this will be equivalent to a squared minus b squared is because if you distribute, a times a will be a squared, a times b will be plus ab, and then the next one, negative BA, the last, minus B squared. Just like your previous lesson, if I replace this BA with AB, if I simplify this, this one becomes A squared. AB minus AB is equal to 0, since they are inverse to each other, and then I have minus B squared. Here's an example 1. Factor difference of squares. Part A, if you want to factor m squared minus 64, since this one is having a difference of two terms where m squared is a square of m, where 64 can be written as 8 squared. Let me change this into m squared minus 8 squared. If I do so, this is saying m is going to be your a is going to be your b value. Since a squared minus b squared could be written as a minus b times a plus b, I'm going to write a is your m, and then 8 is your b, so m minus 8 times m plus 8. And this is going to be a factor form of m squared minus 64. Again, if you want to double check, you can always distribute. I will get m squared plus 8m, and if I distribute this, negative 8m, and minus 64. Since 8m minus 8m will be 0, all I get is m squared minus 64, which is what you started with. Here's a part B. Factor 16y squared minus 81z squared. I can tell the y and z are already square of the variables. However, this 16 is not written in form of square. So here's what I'm going to do. Let's separate the number with the variable. So 16 is square of 4. And y squared is a square of y. So when you have 4y squared, you'll get 16y squared minus 81 is square of 9 and z squared is square of z. So you will have 9z squared. That's going to be equivalent to 81z squared. If you do so, now this 4y is going to be your a and 9z is going to be your b. Once you know your a and b, it gets easier because all you have to do is replace a and b in your form. Since I'm going to write 4y is your a minus 9z, and then times, you're going to do the exact same, except now you're going to add them. 4y plus 9z. Part C, when you're factoring 3b cubed minus 27b, these two terms are neither of square form. Because 3 and 27 are not the perfect square number, what if I take those 3 out as greatest common factor? If I do so, this form can be written as 3 times b cubed minus 9b. I still have one more step because as you see, b cubed or 9b are not the square of a term. So in here, what if I take out b as well? So what if I write 3b as my common factor? Then I can write, you will have b squared minus 9, where b squared is a square of b and 9 is square of 3. So this can be written as 3b times b squared minus 3 squared. From now, you're going to keep the 3b in the front, but b squared minus 3 squared can be written as 3b times b plus 3 times b minus 3. And that's how I know this is going to be your factor form of 3b cubed minus 27b. As we proceed, we are going to apply a technique more than once of difference of squares. Here's example number 2, part A. Factor y to the 4th power minus 625. I can tell that this could be written in another square form. Y to the 4th power could be written as y squared of square, where 625 is square of 25. Still, I'm going to follow a minus b times a plus b form. Then this can be written as y squared minus 25. Y squared is your a, so this is like a squared minus b squared multiplied by y squared plus 25. And as always, if you want to double check, you can distribute. Make sure that you get the same expression as what you began. Next problem, part B, factor 256 minus n to the fourth power. Let's see, is 256 a square of a number? The answer is yes. 256 can be written as 16 square, and the n to the fourth power can be written as n square of square. So to help you understand, let me write on here, a is 16, where b is n squared, which means when you write a minus b times a plus b, you're going to write factor form as 16 plus n squared times 16 minus n squared. And this is going to be your factor form. Example number 3, part A, factor 9x to the fifth power minus 36x. In this case, 9 and 36 I can write in square of a number. However, x to the fifth power or x are not the square of a variable. So in here, if I take, let's rewrite this. If I had x pull out, this can be written as 9x to the fourth power, and then you have minus x times what would give you 36x. The answer is 36. So let's take step by step. Since x is outside of this term, 9x to the fourth power is a square of 3x squared, and then minus, you will have 36. The 36 is square of 6. So then what you're saying is a is 3x squared and b is positive 6. If I'm following a minus b times a plus b, this can be written as x times the 3x squared minus 6 times 3x squared plus 6. And now you have a factor form of 9x to the fifth power minus 36x. Part B is definitely longer than what we practiced. So before you freak out, please take step by step and let's see if we can, just like what we did when you had 4 terms or more, we separated them. I'm going to separate these two. 6x cubed plus 30x squared is in one group, plus I'm going to write negative 24x minus 120. This problem will get a little bit longer than other examples, so just keep that in mind. If you're lack of space, please take out your notebook and rewrite it somewhere. Let's see, by looking at it, it looks like I can take out 6x as a common factor. If I do so, this becomes x squared plus 6x times 5x will get me 30x squared. Plus, since they are both negative, what if I take out negative in the numbers? 120 is also a multiple of 24. If I take out 24, this becomes x plus, since I already pull out the negative over here, negative 24 times 5 will get you negative 120. If I do so, doesn't x plus 5 could be related to x squared plus 5x? So what I'm going to do, I'm going to take out x one more time. So instead of 6x, let's write as 6x squared. If I do so, this becomes x plus 5. And since this would look exact same as that one, but hold on, let me continue this. So plus minus 24 times x plus 5. And since they are identical, I can also take these x plus 5 as common factor. If I do so, x plus 5, come to the front, and remember that you are just writing what's remaining. In here, 6x squared minus 24 will be another term. Do you see how these polynomials are in already factor form by multiplying? Now, it looks like I need to do one more because 6x squared minus 24 kind of gives me an idea that I can still take out something. So let's just try. X plus 5 stays same. I'm going to take out the 6 from these two terms. Then I'm going to have 6 times x squared will give me 6x squared. And the 6 times negative 4 will give you negative 24. Don't you see this x squared minus 4 is a square of the two terms? So I'm going to use a plus b times a minus b eventually. So in here, what I get is x plus 5. And let me just pull out the 6 to the front so that it will look nicer. And then you will have x minus 2 times x plus 2. The reason I got 2 is because remember this is actually 2 squared. So I'm writing x as your a and 2 as your b. And this is going to be the factor form of polynomial from part B. Just like the previous lessons, we will be using zero product property to solve the equation. And just keep in mind, you have to have always equal to 0 and in multiplication. The last example of this lesson, the standardized test example number 4. In the equation, which is value of q squared minus 4 over 25 is equal to y when y is equal to 0. So here's the thing, you're looking for the value of q when y is equal to 0. So if I said this is equal to 0, this is good to go with a zero product property, except you have to factor this form. So in here, let's say q squared is a square of q. 4 over 25. Both numbers 4 and 25 are perfect squares. So 4 is 2 squared and 25 is 5 squared. So let me rewrite this. You're having q squared minus 2 over 5 squared is equal to 0. Since this is following a squared minus b squared form, I can write this as q minus 2 over 5 times q plus 2 over 5. This is equal to 0. In order to be 0, when you're multiplying them, either the first term has to equal to 0 or the second term has to equal to 0. So if you solve this, q minus 2 over 5 has to equal to 0. Now you're going to solve for q. Then I'm going to add 2 over 5 on both sides. Then it becomes q is equal to positive 2 over 5. And this is one answer. Or, remember, you have to do it one more time. Q plus 2 over 5 is equal to 0. In that case, q has to equal to minus 2 over 5. So this is going to be your answer of part A, where q has to equal to 2 over 5 or q is equal to negative 2 over 5. And then you will get the answer at 0. Just to show you a proof, if I substitute 2 over 5 into the q, 2 over 5 squared will be 4 over 25. So if this becomes 4 over 25, 4 over 25 minus 4 over 25 does make it 0. If I had negative 2 over 5, negative 2 over 5 wouldn't be too much different because when I square this, this should be also 4 over 25. So 4 over 25, again, minus 4 over 25 will still make it 0, and that's how I can prove it. Part B, in the equation m squared minus 81 is equal to y, which is a value of m when y is equal to 0. In this case, again, we're going to write this m squared minus 81 can be written as 9 squared. That has to equal to 0, and we're looking for what should be the m value. Similar to previous examples, if I write m plus 9 times m minus 9, saying that m is your a, 9 is your b, this has to equal to 0. In that case, we're using ZPP. I have to have this one equal to 0 or the second term has to equal to 0. m plus 9 is equal to 0 if m is equal to negative 9. And the next one, m minus 9 is equal to 0 if m is equal to positive 9. So I know if m is equal to negative 9 or positive 9, this will be the answer to make y equal to 0. This is the end of the lesson. Thanks for learning with me. If you have any questions, please leave a comment.